In this video, I will demonstrate how to perform a t-test using raw data. We begin with the following problem. It says, assume that data is collected to test a claim that the average amount of coffee cups that a student drinks per week is greater than 15 cups of coffee. Use a level of significance of 0.05. A researcher collects the data below. Perform a t-test. So these are the number of cups of coffee that 10 students have consumed on a weekly basis. Step 1, we always want to know if the population standard deviation is known. The answer is no. We do not see sigma listed in our problem. So we have to replace sigma with the sample standard deviation, which is denoted as S. And since we are provided with raw data, we have to compute that value, either using a calculator or Microsoft Excel. Let's use a calculator to do this computation. So with the calculator, we have to use a stats mode, and it may be different your calculator may be slightly different than this version. So you may have to watch one of my other videos that demonstrates how to perform such a computation with a different calculator. For the TI-30XS, we click on data, and I notice there's old data, so I click on data one more time, and then I clear it. So now we enter the data into the first column. So I'm just typing in each data value, hitting enter. Once all the data values have been entered, I now have to activate the stat feature. So second, stat, one variable statistics, make sure the first column is selected, and press calculate. The summarized statistics is presented. N is 10, X bar is 16.5. The sample standard deviation, we'll round the 2 decimals, 6.54. And that information is presented here. X bar is 16.5, S is 6.54, N is 10. After that step is concluded, we move on to step 2, where we state the claim, determine H naught and H sub 1. Well, the claim is that the mean is greater than 15. So the mean is greater than 15. That's the claim. That's an H sub 1 statement because it has the greater than sign. H naught is the mean equal to 15. We next draw the t-distribution. We have to find the critical value. Remember, the critical value is right at the edge of the critical region and the non-critical region. To look up the t-value in table F, we have to compute degrees of freedom, n minus 1. 10 minus 1 is 9. Alpha is 0.05, and it's a one-tail test. So one tail, 0.05, go down to 9. The value is 1.833. So that is the critical value. Next, we compute the test point. So the test point formula is t equal to x bar minus mu over s divided by radical n. So we can use the calculator to perform this computation. I use parentheses for the numerator, 16.5 minus 15 divided by, and then once again parentheses for the denominator, 6.54. That's divided by the square root of 10. Use the arrow to get out of the square root. Close the parentheses. Select enter. It's 0.725, which we can round to 0.73. So let me just verify that. Yeah, it's 0.73. So we know that the test point is 0.73. 0.73 does not fall in the critical region, so we do not reject H naught. Whenever it falls in the non-critical region, do not reject H naught. And finally, we have to make our summary statement. So if we go back, our claim is H sub 1. Since we're not rejecting H naught, that means we can support the claim. So we would state there is not enough evidence to support the claim. That's right, because we are not rejecting H naught. If we are not rejecting H naught, then we cannot support the claim. That's the correction I have to make. Do not support the claim. And that is the process for performing the t-tests. Thanks for watching the video.